So let me do a proof for you here. Or first of all, so what I'm going to do, I'm going to pick one of the two sides. It's usually easier if you have a more complicated side to start with that one and finish when you get to the other one. So my proof is going to be, I'm going to take the left-hand side and do some simplification and end when I get the right-hand side. Okay? So in this one, my left-hand side, you don't have to rewrite this at the beginning of your proof, but my left-hand side is equal to this expression. So we've got secant of x minus cosine of x divided by tangent of x. So I'm going to start with that one. And when you do a proof, usually there's many ways to do the proof, as long as at each step you're doing something that's algebraically true or true by known identities. A common procedure is to turn things into sines and cosines. That's a good way to get started. So secant, by definition, by the reciprocal property, is the reciprocal of cosine. Secant's 1 over cosine. So we have that minus cosine of x. And then tangent is equal to sine of x over cosine of x. So when I do a proof, I start with one side, and I always say when I write an equals, I mean it. Okay, so the equals, the left-hand side given to us is equal to this expression, secant x minus cosine x divided by tangent x. That, by the reciprocal properties, is equal to 1 over cosine of x minus cosine divided by sine x over cosine x. From here, I have this complex fraction, and I got a lot of options here. I could, instead of dividing by sine over cosine, I can multiply by cosine over sine. I think what I'm going to do, I'm going to multiply top and bottom by the common denominator of cosine here. So I'm going to take this expression and multiply top and bottom by cosine. So I'm really just multiplying by 1, which wouldn't change the value I have here, so I'm allowed to do that. And if I do that and I distribute, I'm going to get cosine over cosine, which is 1, minus cosine times cosine, which is cosine squared. So on top, I get 1 minus cosine squared. On the bottom, we got sine over cosine times cosine. Cosines would cancel, and we just get sine of x. Okay? That, in turn, is equal to, let's see, 1 minus cosine squared. That's a Pythagorean identity. Okay, sine squared plus cosine squared equals 1. So we can subtract either way. Cosine squared is 1 minus sine squared, and sine squared is 1 minus cosine squared. So we've got that. We started with the left-hand side. We've got a string of equalities, and it's equal to sine squared divided by sine. And then you could cancel, and that's just sine, which is my right-hand side. Okay? So to me, it's really important when you do a proof of an identity, you have this string of equalities. You're starting with the left-hand side and using things that you're known to be true to keep getting expressions that are equal to that, and you end when you get to the other side. So I've started with secant of x minus cosine of x divided by tangent x. Then I used some reciprocal identities, multiplied by the common denominator, used a Pythagorean identity, and showed that all that was equal to sine of x. Okay? So don't treat it as an equation. Start with one side. Use known properties in algebra until you get down to the other side. Okay? One other comment I want to make, I know the guy does this in one of the videos that we posted for you, but there it's kind of a difference between saying you're doing a proof or you're verifying, but to me they're really both the same, and a proof should be like this. Let me erase all this. So a lot of you, and I know you've been taught this way, but a lot of you will write your proof as you have an equality every time. So we have the problem that was given to us. Now, and really, I mean, we're told it's true and we're trying to show it, but we don't know this equality until we've proven it. Okay, that's why I don't like writing it every time. So say I did the same proof I did a minute ago. So secant's 1 over cosine minus cosine of x divided by tangent is sine over cosine. Again, forgive my handwriting as I try to get used to this tablet here. So some of you are writing each time an equality, okay? Again, if you do that, this really should be a question mark here. Is this equal to this? I haven't shown that yet, okay? So I really shouldn't, in my opinion, I shouldn't write equals yet, okay? And then your next step, let's see, so I multiplied by cosine over cosine. We could write that, let's say we just go ahead and do that. So we have 1 minus cosine squared x divided by sine x. That's getting closer to being able to see that this is true, but again, it's still a question. And then by the Pythagorean identity, the top is sine squared. This one, I'd say we can definitely see, but don't write. I don't like the process of every time you do a proof writing equals, 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 equals. We don't write an equals when we do a proof until we know it's true. And yes, we were given a problem where it was true, so we know eventually it's true, but I haven't shown it's true. When you write an equals, make sure that it's clearly equal from side. Like here, this is clear. Sine squared divided by sine is sine. That's clear. Maybe not quite as clear here unless you think about the Pythagorean identity. So your proof, of course, you know, if you're in an online class, you might not be writing these up by hand and you just fill in things. However, we're able to ask it in an automated way. But if you're writing a proof by hand, for me, I would request you start with the left-hand side and you end when you get to the right-hand side. Okay? So just a few comments I wanted to share with you. Again, everybody did really a pretty good job overall on the proofs.